Everyone, and welcome back. And this is our part 3 of quality management, which is our lecture 4. So we recall from the last part. In part 1, we discussed about 8 dimensions of quality management. We discussed about the internal and external quality cost, quality failures. Then we talked about the quality dynamic, the improvement cycle, kind of improvement in the long run. And we also talked about the organizational dimension and the technical dimension of quality improvement strategies. And in this part, which is part 3, we hopefully can finish this lecture of quality management within 3 parts, within 3 videos, which I think add up to about 1 hour together or more. But so now we're trying to work more about quality management. Hopefully we can finish the content in this lecture. This lecture can be a bit complicated, so I'm not sure whether we can do it in 3 parts. Maybe we have to do a 4th part, but I'm not completely sure about that yet. Okay, so let's start with the first topic in part 3, which is quality dynamics, the quality learning process. So now let's look at this quality learning process, see what can you see now. So in this quality learning process, we're determining first of all our existing knowledge level, and from existing knowledge level, we are going to set our tolerance level. So what do we mean by existing knowledge level? It is basically about expertise, know-how, and what is the problem that happens in our company. So it can be the existing product. The existing level can be our let's write it down. Can be our existing product that is not published. We can try to make edit to this product, or it can be some problems inside our company. So existing level is definitely really important because existing level actually allow us to actually try to identify our problem. Then we have a learning criteria. What is our learning criteria? It is basically, for example, our tolerance level. Or you can say learning criteria can be some certain number, the certain number that standardize your tolerance level or some kind of other stuff. So it is some learning criteria is basically some kind of a measurement or indicators for you, and indicators for you to decide whether the problem for the quality of your product is significant or not. So it can be a tolerance level. After learning criteria, we have an observation measure. And here's basically we try to have a gap. We try to measure the goal and outcome, the difference between our goal and outcome. So maybe our goal, for example, let's say an example of our goal is to produce a 300, for example, to have the speed to have a 5 GHz. That's something like for our CPU speed, if we're producing a kind of CPU. And maybe some other observation measures can be our goal to load the website within 3 seconds. It can be also a goal. This can be also a goal to load the website within 3 seconds. If we are making some kind of bag, we hope the bag to be able to be durable. Or let's say a car. Let's say, for example, a car window. We are manufacturing a car window to be able to undergo hammer heating. So these are some certain examples. From how we measure from the goals. These are examples of the goals we can set. These are examples of goals. So our goal can be we have some certain speed of our product, and we can we also certain durability. As I mentioned before, durability is an order qualifying attribute element, which means durability is really important on how much sales can you generate at first. So definitely for example, your car window can be able to undergo hammer. That's definitely really protective. Many customers may choose to buy your car. So then we set a goal and we try to find out the gap, which is important. We find out the gap by actually subtracting the goal and our outcome, axis our outcome, to see our gap between the goal and our outcome. So this is what we are finding. We're finding the gap between our goal and outcome. Then we are going to conduct what we call the significance test. We're going to conduct this significance test to find out whether the gap is within our tolerance level. So we are basically asking the question whether whether the tolerance level is E, right? We have decided to use this variable, or it's not E, something just a representation. So let's see if the gap is larger than our tolerance level. If the gap is larger than our tolerance level, then this problem is significant. If it's not, the problem is insignificant. So this is a way to classify our significance, whether the problem is within our tolerance level or not. So this is definitely really important. After that, let's talk about significance first. If our problem is significant, whether we have to investigate what causes this significant problem, whether it is assignable cause. Assignable cause, in other words, basically means a cause means a cause that that is specific, a cause that you can find the reason. A cause that you can find the reason is called assignable cause. Basically, you can find the reason why you have this you have the problems, you have this significance problem in your company. So and on the other hand, you may have a common cause. A common cause is random, basically a random cause. On the other hand, assignable cause is a systematic cause. And if it's systematic, let's continue with this. If it's systematic, we have to find out the contingent causes and the underlying causes. So then we have to conduct current learning in order to find out what are some contingent causes, like those causes that are happening now, and what are some underlying causes that we have to identify through our kind of, the root cause learning. So then we have to implement learning, and this is called current learning because we're learning right now to find out what are the issue. These are current learning because they are current now, right now, which we have to tackle the problems, which are problems that we have to tackle at the moment, and we have to do some kind of like a cause-effect analysis. We can do some experiment to find out the issues, as I discussed in the learning capability lecture 3. So some strategies can include the trial and error, to find out the problem. We can also use a cause and effect. Basically, it can be a little bit of trial and error to see what causes what, whether the cause is this, and whether it isn't the cause. And then we also should implement what we learned, what we did from maybe systemizing as well, analyzing our problems, and from the outcome, after we get the outcome, we're going to record, analyze, and preserve the outcome to improve our system. So this is about when we have a significant cause that is either a common cause, or random cause, or assignable cause that the significance of the problems is more than the tolerance level we set for our company. So tolerance level, how do we set the tolerance level? We should have a little discussion on this tolerance level. How do we set our tolerance level? Can be a bit subjective, I would say. Tolerance level should be linked to sales. I would say it should be linked to the functioning of the product and the number of products affected. So if you produce 1,000 products and only 30 is affected, I would say it's not significant. But if over 300 plus are affected, I would say this it can be a significant issue. So I would say the significant test. So we can say like maybe 100. If the 100 affected, we said then we cannot tolerate it anymore. So 100 products to be defected is our tolerance level. So this is a way we can set that up. And moreover, we can also set by how the functioning are affected. So if it's a small function that does not affect many features, we can say it's not significant. But if the function is really severe or it is a really important function that is broken, we definitely say the problem is significant. So the tolerance range can be whether a significant function is broken or not. So this is some ways we can identify and set our tolerance level. So as I mentioned before, whether no matter it is common cause or systematic cause, whether it is random or systematic issues, whether it is a random cause or the systematic cause, we all have to conduct the learning. The differences is basically when we see the random cause right here. When we see the random cause, we can see that when it's random, we cannot find the underlying cause. We may be able to find what causes that, but it doesn't really have an underlying cause. So maybe the random cause can be based on a single loop learning, I suggest. I'm not sure, it really depends on the situation. But basically, if there's not happening much, just randomly happening, there may not be the need to actually tackle the underlying causes that requires the double loop learning. Sorry, it's really hard to write like this. That requires double loop learning. Maybe you don't have to have a double loop learning if you have a random course. So basically, it really depends on the situation as well, whether you require a single loop or double loop learning. I should just have to use the task. Sorry for that. Or start single loop or double loop learning. And then after the outcome, we try to record, analyze, and preserve. Now let's look at the other hand. If our problem is insignificant, which means our tolerance level is less than the significance of the problem, is more, so we're able to tolerate this problem, then we still have to conduct learning, but it's a bit different. The way we do is a bit different. So first of all, is it completely unknown, or there's a common cause? So we try to find out whether the problem has a cause or is unknown. So we try to identify its pattern, and then we'll conduct what we call as continuous learning, which can also in fact cause and effect and experiment. So this is more about double loop learning, because since it is insignificant, we try to actually actually use the double loop learning to find a bit. I wouldn't say double loop learning will be the only one apply, but maybe single loop learning will apply, but definitely more double loop learning will be oriented, especially if there's a common cause and it shows some kinds of a pattern, if there's some kind of pattern. So I discussed before that in a significant scenario, when the problem is more significant than your tolerance level, then you have to use both single and double loop learning, because sometimes random cause problems don't require double loop, but since it's significant, I would suggest double loop to be used. And here I will also say both single loop and double loop learning should be implemented. And then we have continuous learning. After that, we analyze the problems, and then we try to, you can see this arrow here, we go back to here, this go back to here, and we try to fix our existing level. Also here as well, whether it's significant or not. After we identify the problem, we improve on the problem, and our goal is to try to improve the existing knowledge level. So this is basically, I hope you guys understand a bit about this. So this is basically a discussion about our learning, I would say learning logical timeline. So what we do at each step. So this is about how to identify a problem, how do we classify whether it's a significant problem or not, and afterward we have to find out what we do. We have to conduct single loop and double loop learning and record, analyze, and preserve the problems. So that's about that. Maybe you can take some notes on this. I have to erase this, so I have to erase this, so I can go through the next part. Okay. Oh yeah, it is convenient. I really like this Zoom software. It's really convenient for learning. Okay, so this is about learning dynamic on the quality learning, and now we are going to analogical perspective. We are now discussing equality from an analytical perspective. Sorry. So first of all, as I discussed before, there are common causes and assignable causes. So common causes are causes that are kind of random. Assignable causes are causes that have some reason behind, and then we try to process it, and then we give a deviation. So this page is basically a summary of the first, to basically emphasize your understanding of a diagram just now. Then the deviation is basically the gap between the goal and the actual outcome. And afterward, we'll identify the problem, whether it's significant or not. So just now, when I went through the difference between the goal and outcome, is basically a deviation, and the defect is basically the deviation on the goal. How significant is this problem? Whether there's a higher gap, whether the gap is higher than our tolerance level. Even if it's higher than our tolerance level, how much higher is it? So this is that's the way we can measure our defect. So this is just emphasis on the last slide we discussed about it. So after these two slides, I hope you guys have a better understanding of this. On this quality and dynamic aspect on this part. So I hope you guys have a better understanding on how do we kind of conduct this learning capability, logic process in order to tackle our problems. Now let's briefly talk about statistical process control. We are not trying to get too technical right here, but we're trying to get the logic going. So now before, what we have to understand is that we always have a mean, which is a goal that we want to achieve. So mean is definitely important. It is a goal we want our production to achieve. So first, our product to achieve. So first of all, let's use an example. Let's use a more straightforward example. What color should I use? I pick orange color. Okay. So we use an example. If we are a calling center, if my business is a calling center, then our goal is to call and complete each call in 3 minutes to our customers. So 3 minutes will be our mean value, but can every call be 3 minutes? Of course not, because it can never be consistent. For every call to be 3 minutes, maybe some customer require more help, some customer require less help, but 3 minutes basically what we want to achieve as a compromise. So when it's 3 minutes, we think this is the best time that we compromise between those customers who require more help and who require less help. But definitely when it's a reality, when we're really working on our business, we can see when the mean value is 3 minutes, really hard to achieve. So let's say mean value is 3 minutes. And now we may have 5 minutes. We may have point like there. We may have point here. We may also have another point right here. So we can have very short call as well. It's also possible with those customers who don't need any help. There can be much more longer call with some more troublesome customers require more detailed help. So can have a different mean. So maybe this is 8 minutes. This is a 6 minute, or maybe this is just 1.5 minutes. So we can have a far away from our mean value. For this call center, it may not be a problem, but when we compare, when we use another example, maybe we're a car company, we try to make a car that has the tolerance level, maybe a production of a hammer. But if some cars don't have this availability, some can be broken, some can be easily broken, then this can be a severe issue. So we have to, in analytical perspective, how far is it away from the goal is definitely important. So the deviation that measures the defect is an essential indicator of the significance of our problem. So how far away is it from our aimed goal? How far away is it from our aimed requirement for our product is basically a deviation, and deviation is really important as it tells us whether our product meets the standard or not, and sometimes we can call it outlier. I think statistic, if every now I want to go through a simple concept on outlier right here. So if we have many coordinate, for example, if we have many coordinate here near the mean, we have a coordinate here, we have coordinate here, we have coordinate here, we have coordinate here, we have coordinate here. These are basically really close to the mean. But if then suddenly I have a coordinate right here, and I have a coordinate right here, they actually considered as outlier. They consider as outlier. And outlier are really serious in that case, because outlier means they are really far away from our requirement. Either it is maybe too weak, maybe for example it is 2. What example can I think of? So either it's too slow or too fast. For example, e.g. if tech company, because sometimes too slow. If you load the website too slow, it's not going to pass even customers' qualifying requirement. But if it's too fast, like your mouse is moving too fast, if I move my mouse here, just by moving this speed, it will go up to here too fast. Definitely, many customers won't be suited to use that. So that's also an example. So this is our discussion again on the deviation. So if I want to go through a little bit more, there's also something called a standard deviation, which is measures how far away our values from the mean, value. This is also very important, and you can also look up more on the variance, which is a square, which is this, of a standard deviation. So you can find out more about this in your statistical learning. You might have already know about standard deviation. So in the product point of view, in the quality point of view, if the standard deviation of certain products are too high, or the variance is too high, or you can look out also for this z-score. If it's too high, it means they are too far away from our mean value. So you can look up for these values moreover on your own time. Okay guys, so this is a part 3 of our because I don't want to make it too confusing, because for the next part will be a little bit different from what we're doing now, so I don't want to push too much information on you. So in part 3 in this lecture, we discuss about, first of all, we explain about the quality, the logical process for studying the problems, and the main concept we are talking about is basically deviation, which is the difference between our goal and the outcome, g minus x, and deviation allow us to measure the significance of our problem. We can set a tolerance level in order to find out whether the problem is significant or not, or we can evaluate the significance based on how much is our deviation. And then we give us some examples to strengthen and emphasize this point. In the next part, I'm going to be talking about I'm going to go through more about different courses, including type 1 and different problems existing in a company, including type 1 error and type 2 error, and we'll also talk about more in terms of the statistics in quality management. So before I said the quality management lecture will only have 3 parts. Now I'm adding 1 more part, so the lecture will have a total of 4 parts. Okay, so I'll see you in the next video. If you have any questions, please comment below. I also hope you guys can study in your own time. For the basic fundamental statistical concepts include standard deviation, variance, and z-score, and you can definitely study deeper. They will give you more complex effects, more complex values, more complex applications in statistical studies. So I will see you guys in the next video, and see you then.